vectors in 2 dimensions. When you are talking about a vector, you're talking about a magnitude, which is a length, and a direction, which is here and upwards. If I take a basis, a basis is a set of 2 vectors, which are of different directions. So I'll take I and J, and that directions are different. I take 2 vectors which directions are perpendicular to one another because that's how you are used to see it, but they don't have to be perpendicular. They just need to not be parallel. So if you take a vector like this one, like U is a vector here, and if I want to express U in the basis Ij, I'll check this this transformation, like getting from here to there. How many vectors it takes? It takes 3 vectors I, and it takes, like, for example, 2 vectors J. Of course, if it goes downwards, it will be -2 vectors J, okay? So I can write that U is equal to 3I plus 2J. So this is called the decomposition of U in the basis, and the numbers 2 are the coordinates of U. You can say coordinates or you can say components. Okay. Of course, if your vector is the 0 vector, meaning the length of it is 0, its decomposition, its coordinates would be 0 and 0. You get equality between vectors when it's the same length and same direction, and it means that the coordinates of your 2 vectors will be the same. So you can prove that the vectors are equal if A is equal to X and B is equal to Y. It means the vectors are the same if and only if their coordinates are the same. You get opposite vectors when they are the same length but opposite direction. So it will be denoted U and minus U. And of course, the coordinates of minus U will be minus A and minus B if U has A and B as its coordinates. You can find parallel or anti-parallel vectors. Sorry, I don't really know how to pronounce parallel. It means that U is the same direction as V, but not the same length. This is parallel, and anti-parallel will be when U and V are the same direction, are the same, like, are constructed on parallel lines. This is parallel, this is anti-parallel, okay? Addition and subtraction of vectors. If you want to add U, which coordinates are A and B, and V, which coordinates are X and Y, the sum U plus V will be A plus X and B plus Y. And you'll get this if you want to draw it, U plus V. And you go first from this point to this point, and then from this point to that point. So your total vector, the sum of them, U plus V, will be here, U plus V. So same thing for subtraction. If you subtract the vector, you will subtract the coordinates. a scalar multiplication means you're multiplying your vector by a number. Like, for example, if you want to compute 4u, 4 times the vector u will be 4 times its coordinates. It means that you get the same vector, but 4 times longer. Okay, this is your 4u vector. The length of a vector, if your vector is always denoted a and b for its coordinates, the length is denoted between double bars, and it's the square root of a squared plus b squared. What you will call a unit vector is a vector for which the length is 1. So if you want to build a unit vector, of course, here, I and j are unit vectors. But if you want to build one and you don't have one, you have an ordinary vector like that, you just have to take your vector and divide it by its length. Because the total length will be length of u over length of u itself, and it will be equal to 1. And the dot product is something very, I don't know why it doesn't work. Okay, it does. So dot product is something very important that we will use later in many, many calculations. So if you have a vector u, doesn't work as I want it to work. If you have a vector u and a vector v, the dot product will be like denoted with a dot, as its name says it, and it will be a times x plus b times y. What you can notice here is you have multiplied 2 vectors and you get a number. This is a number. What is the main case in which you use dot product is to check if it's 0, it means that the vectors are perpendicular to one another. If it's not equal to 0, it means that they are not. And something else I wanted to show you. So what I wanted to show you is that, sorry, I have a problem with it doesn't work properly. Okay. So I wanted to show you that you have another tool here with vectors, which is a determinant. A determinant is if you have your 2 vectors, u, a, b, and v, x, y, your determinant, the determinant of the 2 vectors is going to be written like that between bars, where you put the coordinates of u here and the coordinates of v here. And you compute it that way. So I hope you studied this in high school too. It's a times y minus, be careful with the minus, that's where people usually get mixed up, and minus x times b. So here you have 2 options. If your determinant is 0, it means that your vectors are not independent. It means that u is equal to v times a certain real number, which can be positive or negative. It means that they are parallel or not the same length, but at least parallel or anti-parallel. You don't know, but they are not independent. It means you can't use them to form a basis, because if you use them to form a basis and you have parallel or anti-parallel parallel vectors, you only have one axis and you don't have the other one. It doesn't work. Okay, so you will have to compute determinants of vectors to check if you can use them as a basis or not.